Okay, today we're going to be looking at separation by variables, and this is going to be how I'm going to teach you how you're going to solve for y for this differential equation, and we're going to do it with, you guessed it, separation by variables. So it's kind of in the name, separation of variables. We want to make this equation workable, and the easiest way to do that would be to move y over here, and we do that by dividing both sides by y. So then we'd get dy dt times 1 over y is equal to 1. And then we want to get this dt to the other side, so we're going to multiply both sides by dt. And we're going to get, oops, sorry about that. We're going to get dy over y is equal to dt. So this is now a workable equation, so we can integrate both sides. So 1 over y, that is going to be the natural log of the absolute value of y. And then I guess for the first one I'll do plus c, and then this is equal to the integrate 1, which is going to just be equal t plus c. We're going to move this c to the other side, so we're going to get here, we're going to get ln of the absolute value of y is equal to t plus c. C is some constant. We're just, you don't have to worry. Just right now, it's we're just gonna move the c over and just call it c, whatever that sum is, or the two c's. So then now we need to just get y by itself. So we're gonna take everything to the e, and e to the ln of y is gonna give you y is equal to e t plus c. And et plus c is equal to e times e to the t times e to the c. Now e to the c is just a constant, which we will call uppercase A. So it's y is equal to a e to the t. And that is our solution for this problem. Now we're going to make it a little bit more challenging. We're going to add some constants. We're going to add a constant in front of the y, and then just the constant on the other side. And the general steps is pretty much the same. One thing I'm going to do to make this a little bit easier to work with is take out an a, so y is by itself. So you're going to have a times y plus b over a is equal to dy dt. And now we're going to move this whole section over here and dt over. So it's going to be dy over y plus b over a is equal to a dt. And then we're going to integrate both sides, which is going to give us ln of y plus b over a is equal to a to the t plus c. So I'm not writing plus c because we would technically just move it over here. And like the last one, we're going to do e to the ln of y plus b over a is equal to e at plus c, which is equal to a e at. If you remember, this is just a constant. E to the c is some constant. So then we're going to get y plus b over a is equal to a e to the at. And we're going to move b over a over. So we're going to get y equal to a e to the at. Oops, sorry about that. Minus b over a. And that's going to be your solution for this problem. So now let's do a basic one. So dy over dt is equal to negative y plus 5. So we're going to do pretty much what we did last time in the previous example. I'm going to take a negative 1 out just to make this, I'm working with a positive y just to make it a little bit easier. for myself. And now we're gonna move some stuff around. So dy is equal to y minus 5 equal to -1 dt. And we're gonna integrate both sides. So we're gonna get ln of y minus 5 is equal to -t plus c. And then, you guessed it, I'm gonna do e to the ln of y minus 5 is equal to e to the -t plus c, which is gonna be equal to a times e to the -t. So y minus 5 is equal to a e to the -t. So y is equal to a e to the -t plus 5. That is our answer. So you may be wondering what we're going to do about this a. So we're going to look at another example, but this one has an initial value. So when t equals 0, y is equal to y naught. So we're going to solve this like we've solved the other ones. I'm going to make y by itself. So y minus 5 halves is equal to -2 dt. Going to integrate both sides. Get ln of y minus 5 halves is equal to -2t plus c. And then gonna just keep on chugging through this until we get to a point where we can now work with a. So y is equal to a to blah 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 plus 5 halves. So now this is where the initial value is going to come in. So when y of 0 is equal to y naught, so y naught is equal to a, we're going to substitute this 0 in for t right here. A e to the -2, 0 plus 5 halves. So anything to the power of 0 is 1. So we're going to have y naught is equal to a times 1, which is just a, plus 5 halves. And we're going to solve for a. So a is equal to y naught minus 5 halves, which we are then going to plug back in to this equation. So y is equal to y naught minus 5 halves times e to the -2t plus 5 halves. And that separation of variables with an initial value. So this is pretty basic stuff. I'm gonna do a more real world